To start Radar Signal Basics program, the operator should open this application. After that, the application opens three following windows. RAD Scope, this window for radar signal analyzing. RAD Function Generator, which generates the radar signals. And the last one is RAD Match Filter, which provides radar functional properties in FPGA. We will let you know about the first laboratory work, which is number 19. And also the operator will show you how to use the tools to analyze the signal for this work. It is about the formation and match filtration of a pulse signal with a linear frequency modulation or chirp signal. So, the purpose of laboratory work is research of properties of a pulse signal with a linear frequency modulation and characteristics of a digital matched filter. In this work, you can research the main characteristics of a chirp signal, which are type of a signal, spectrum of a signal, and frequency and phase responses. Now, on a RAD Scope window or radar signal analyzing window, the operator will show you how to use the graph tools to scale the signal and research it partly or completely. The tools are horizontal sweep, which is for manual or auto scaling signal, tag tool to bring the signal to the middle of the graph, and graph tools to zoom in or out the signal. And also operator uses the cursors to select the part of a signal for measuring. In the right side of the window are shown the ratio of coordinates, values of cursors, cursor 1 and cursor 2, and also the value of the standard deviation or mean squared error for the noise, measured in voltages. On the top graph you will see the chirp signal, and in bottom graphs you can see the view of the selected part of a signal by cursors and its spectrum. To go to the graph showing the relationship between the frequency and phase of the chirp signal, go to tab Dispersion. To determine the amplitude and phase characteristics of a matched filter, follow the operator actions. It is to turn on filter out button and then sequentially turn on frequency response and pulse response from RAD match filter window and see the signal formation on the graphs. The operator will do scaling by the same tools to select and show the signal completely on the graphs, and will go to the tab Dispersion to show you characteristics of a matched filter. To obtain compression ratio for different durations of a chirp signal, the operator will turn off frequency and pulse responses from RAD match filter window. Then will scale the signal to its desired position. Now you can remember the difference of coordinates or cursors from the indicator located on the right side. Because the operator will change the pulse duration from right function generator window, then we'll do the same scaling actions and we'll get the measure difference for the changed pulse duration. Now you can compare the values and we'll see the comparative differences. Now we will show you the view of the signal in a baseband and in an intermediate frequency. The operator will show you the view of a baseband signal and its spectrum now. Then we'll turn on 10 MHz output button from rad match filter window, and after scaling the graphs we'll show you intermediate frequency view and also its spectrum. What we have discussed, it was only the reflected signal from one object. Now we'll show the possibility of simultaneous processing of signals reflected from two objects. We will discuss it on the intermediate frequency. But the actions are the same for baseband, only the operator should turn on 10 MHz output button from rad match filter window. From the rad function generator window, we should set the switch for two objects, as it is doing the operator, and then we should simulate delay between the two reflected signals. It is important after any changes click on Apply Changes button in this window. After this action on the rad scope window we should scale the graphs again and we'll see two reflected signals. The operator will do these steps 2-3 times and will show you the graphs differences after changing the delay between two signals. The value of 540 nanoseconds is the minimal value of device detection. Below this value, device detects one object instead of two. In the first step, the operator will show you that the matched filter is on the input state from rad match filter window and how to increase noise level from the rad function generator window. Now we'll show you the signal noise ratio on the matched filter input and output, increasing the noise level from the rad function generator window. After these actions, on the window rad scope we can see mean squared error value, which is located at the right side of the window. Now we'll change the matched filter position to the output and we'll see the difference of MSE from the input state. Now the operator switching the Gaussian filter, which is for correction of side lobes. The same steps the operator will do for this time to get MSE's values. You can practice and do the same actions for baseband signal, changing switch 10 MHz output from rad match filter window and research the values for it. The operator is turning off Gaussian filter and 10 MHz output from rad match filter window to get signal on baseband. Now we'll discuss the impact of a quadratic phase distortion on the matched filter. And from rad scope window is scaling the graphs. To add square distortion, we should change corresponding control from the rad function generator window. Now operator is increasing its value, then after applying changes we'll show you its influence on the signal. The operator will increase or decrease its value 2-3 times to show you how it is changing the signal form. It is very clear from the graphs to see that after increasing the square distortion it is difficult to detect chirp signal. These same steps can be repeated for the intermediate frequency. Now we'll follow the operator actions to know how modulation distortion influence on signal formation after matched filtering. For turning on modulation distortion, the operator switching on the button, which is at the right side from distortions control. After applying changes and scaling the signal from the rad scope window, we can see modulation distortion influence on a signal. The operator will do this step again, changing distortion value from the rad function generator window, and you can see its influence on a signal formation. After these steps, we should set this value to its default value, to go ahead showing you the Doppler effect on a signal. To see how it can influence on a signal, the operator changing the Doppler shift value from the right function generator window. We can see on the bottom graph on window right scope that the signal has shifted to the left.